Module 1, Operations with Integers. This is Section 1.4, Introduction to Integers. Our number line extends infinitely, both to the left and to the right. In the virtual center, since it's never ending, there is no true center, is the number 0. 0 is not positive or negative. It is a neutral number. It is the only neutral number. Extending infinitely to the right are positive numbers. Extending infinitely to the left are the negative numbers. Notice that the negative numbers appear to be counting backwards. So it goes from -1 and then -2 and -3. But if you look at it, it looks like -3 is further to the left than the -1. An easy way to kind of think about negative numbers is to think about it as a direction above sea level or ground level. So for example, a worker in a silver mine in Nevada works 1,445 feet underground. As a sign number, this would be a negative 1,445 feet, since they're 1,445 feet underground. When you graph these on the number line, 0 is always right in the middle. So if I was going to graph 0, it's right here. The number 2 is right here. 3 1/4 is 3 and a little bit more. So it'll be right about there. But the -4 would be over here to the left. Negative numbers are always to the left. And the more to the left you are, the smaller the number is, the smaller the value. So we know that 2 is smaller than 4, but in negative numbers it will appear to be reverse. -4 is smaller than -2. Let's practice comparing. -6, how does that compare to -3? We're going to use the less than symbol or the greater than symbol. The side that is open opens up to the number that is larger. So negative numbers are always smaller than positive numbers because remember, here's 0, and then here are all our positive numbers, and then here are all our negative numbers. So positive numbers are always further to the right. The more to the right you are, the bigger you are. And so 6 is less than a -3. 0 virtually splits the number line from negatives on the left and positives on the right. So 0 is always bigger than the negative numbers. So 0 is greater than a -7/8. But when you're comparing a negative to a negative, remember it's going to be the reverse of what you think. -4.2 is further to the left than the -3.6. And the more left you are, the smaller you are. So -3.6 is actually greater than the -4.2. Sometimes we don't necessarily care about direction. We just want to know about steps away from 0, and we call that an absolute value. A number that we want to talk about just the steps away from 0 and not the direction of steps that you took will be a number inside these stiff bars like this. Not curved, not parentheses, not brackets, just 2 bars. An easy way to think about it is any number that's inside the absolute value bars, we'll always think about it as a positive. So the absolute value of a -6 is a +6. Now we know -6 is over here, but what we're concerned about is just how many steps did I take to get there. I took 6 steps. The negative says go to the left. The absolute value of an 8 is 8 because I took 8 steps, 1, 2, 3, 4, 5, 6, 7, 8 to get to it. The positive says to go to the right, but we're not worried about left or right. The absolute value of a -2/3 is 2/3. It doesn't matter that the number inside the absolute value bars is a fraction, a decimal, or a whole number. You always just take the positive version of the number, and that's the absolute value. One of the things absolute value makes us aware of is that direction matters, right? If I take 6 steps, well, if I go to the left, I get a -6, where if I go to the right, I get a +6. And so these two numbers that have the same absolute value but have different signs, are called opposites. So 4 and -4 are opposites. They have the same distance from 0, but they go in two opposite directions. Every real number has an opposite on the other side. The opposite of 11 is -11. Positive 11 goes to the right, so -11 would go to the left. The opposite of -8 would be +8, because -8 goes to the left, so +8 would go to the right. The only number that doesn't have an opposite is 0, because it is neutral. It is not signed. It is not positive or negative. So 0 is the only real number that is its own opposite. Simplify these three seemingly absolute value questions. I say seemingly because letter A, these are parentheses. Those are not brackets or absolute value bars. Notice the difference between the straight line and the curved. So this is really saying a -1 times a -9, which is just a +9. The absolute value of 15 is 15. But notice that the negative is on the outside. It is not on the inside, so we'll keep the negative. The absolute value of a 4, -4, is a 4, but I have another negative on the outside, so we'll be back to the -4. You only ignore the sign on the inside. You don't ignore the signs on the outside. Let's go back to some comparing. I have a bar graph showing the temperature of 8 planets. Which one has the lowest average temperature? Well, these are positive numbers. Positive numbers are always greater than negative numbers, so we know it's not those. And the lowest average temperature is going to be the average temperature that actually, when you're looking at negative numbers, appears to be the highest. So the lowest average temperature is actually -330. Now notice the bar is the lowest one. It's the one reaching down the furthest on the graph. So my answer to this question would be Neptune. Which is the third lowest? Well, if this is the lowest, then this would be the second lowest because it's a little bit higher, and this would be the third lowest because it's just a little bit higher than the second one. And so the answer to this question would be Saturn at a -218. And that's how you compare integers and use absolute value.